Hey everyone, this is going to be the last lesson in chapter 3. So we're going to wrap up section 3.5. I have another example where we have to find the 5-number summary, and then the remainder of the questions will review box and whisker plots. So let's look at example 20. Example 20 says 11 high school teachers were asked to give the number of students in their classes. The sample data follows. So we have 36, 31, 30, 31, 20, 19, 24, 34, 21, 28, and 24. So those are the answers that the teachers gave in terms of how many students are in their classes, and we're considering this a sample. So I want to find the 5-number summary for this sample. So like I showed you in the previous lesson, your 5-number summary consists of the minimum data value in the set, the first quartile, which is Q1, the second quartile, which is also the median, the 25th, the 50th percentile, the third quartile, which is the 75th percentile, and the maximum data value in the set. So like I explained in the last lesson, it's going to be much more efficient to use the calculator to find the 5-number summary rather than ordering the data values by hand and then trying to find the 5-number summary by hand. So I'm going to give you a minute to pause, and I want you to enter this data into a list in your calculator. And then once you do that, you can unpause and we'll continue. Now I already have this list in my calculator, so I'm going to share my calculator screen. And I have this data in list 2. So to find the 5-number summary, we're going to do a 1-variable stat. So first we press stat, we arrow over to calc, and option 1 is 1-variable stats. We have to put the appropriate list, and mine was, I already forgot, what did I say? L2. So my list is in L2, and we leave frequency list empty, and then we calculate. And remember, in order to see the 5-number summary, you have to scroll down to the bottom of the output. And at the very bottom, you have your 5-number summary. So the min is 19, Q1 is 21, the median or Q2 is 28, Q3 is 31, and the maximum data value in the set is 36. And now I'll write that down on the worksheet. So the minimum data value in the set is 19. Q1 was 21 students. Q2 or the median was 28 students. Q3 was 31 students. And then the maximum amount of students in a class was 36. So that would be the 5-number summary for this particular data set. And I left some room because we might as well create a box and whisker plot too, just to practice. So remember what I showed you in the previous lecture. I showed you guys to create a horizontal axis, and you have to make sure it covers the minimum through the maximum. So my minimum is 19, the maximum is 36, so we have to at least go from 19 to 36. So I'm thinking maybe let's start at 18, and then I could count in 2s all the way up to 36. So we have 18, 20, 22, 24, 26, 28, 30, 32. Make this a little bit longer, this number line. 34, and then 36. So we at least span the min to the max. So the first thing we're going to create is the rectangle for the box plot, and we use Q1 and Q3. So Q1 was equal to 21. So 21 is going to be halfway between 20 and 22. So let's say this is Q1. And then Q3 is 31. So that's going to be halfway between 30 and 32. So let's say it's about right here. And now we can create the box. And then we have to draw a vertical line where Q2 or the median is, which is at 28 in this case. That's going to be there. And then we're going to connect the box to the min and the max with the whiskers. So the min is 19, which is going to be halfway between 18 and 20. The max is at 36, so we're going to put a dot at 36. And then we're going to connect the dots to the box. And that would be a box plot for the number of students in each one of those high school teachers' classes. So now what I want to do is let's talk about how we interpret these box and whisker plots, because I think that's really important. So not only should we be able to create one, but we should also be able to interpret them. So box and whisker plot interpretations. So number one says the median represents a measure of center and is denoted by a vertical line within the rectangular box. Number two says approximately 50% of the data values are contained within the box. So let's draw a generic box plot. So what this is saying is that since here's the min, here's Q1, here's Q2, which is the median, here's Q3, and then the max. So what number two is saying is that approximately 50% of the data values are contained within the box. So what that means is, and this is stated in bullet 3, within each component of the box separated by the median is about 25% of your data values. So this part of the box is going to contain about 25% of our data values, and this part of the box is going to contain about 25% of the data values for a total of approximately 50% contained within the box. And then approximately the lower 25% of the data values are represented by the whisker connecting the first quartile to the smallest data value. And approximately the upper 25% of the data values are represented by the whisker connecting the third quartile to the largest data value. So what that's saying is that we expect approximately 25% of our data values to be between the min and Q1, and we expect about 25% of our data values to be between Q3 and the max. And this makes sense, right? Because if we add up each one of those 4 quarters, we get 100%, 25, 25, 25, 25. So this is, generally speaking, how a box plot is distributed and how we can interpret, these areas within the box plot. Number 6 says that the length of the box is a measure of variability of the data set. So the longer the box indicates more variability, while the shorter the box will indicate less variability. And then the length of the whiskers will provide an idea about the shape of the data set. So if one of the whiskers is noticeably longer than the other one, then the data is probably skewed in the direction of the longer whisker. So I'll give you an example on the whiteboard. So let's suppose I have box plot A, which looks like this. So this is box plot A versus maybe something that looks like this. So box plot B. The one on the right, box plot B, is going to have more variability because you see how the box is longer. So there's more variability in this distribution because the box is longer. Whereas in box plot A, the box or the rectangle is shorter, so there's going to be less variability within the distribution. And then let's say maybe we have something that looks like this, where one whisker is noticeably longer than the other one in a box plot, right? So imagine taking your pen like we did with the histogram and tracing the overall shape of this distribution. You see how this has a tail to the right because of that long whisker. So this data set's going to be skewed, right? This curve looks like it's skewed in the direction to the longer whisker, right? So skewed to the right. And I'll do one more example. We'll do skewed, something that looks like it would be skewed to the left. So what if I had something that looked like this? If my box plot looked like this? So again, if I were to trace the general shape of this distribution, the tail is going to be to the left. So this would be an example where my data would be skewed to the left. So this is how we could interpret the different types of box plots in terms of, does it have a wider box, a smaller box, a longer tail, a shorter tail? So that's going to influence the variability of the distribution and the skewness. So let's look at the next example, and then we'll get back to, within this example, we'll talk about the interquartile range. And then we'll talk about how we could use the interquartile range for detecting outliers. So let's look at example 21. So I gave you the following box plot, and it represents the weekly salaries in dollars of 24 randomly selected employees at a company. So the first question says, what percent of the employees earn less than $1,225 a week? So here's 1225, and that corresponds to the third quartile. That's Q3. And if you want, if it's, makes things easier for you, you could label all of these, like 3,700 is the max, 310 is the min, 510 is the beginning of the box, so that's going to be Q1. And then the vertical line that's between Q1 and Q3, that's going to be Q2. So the question is, what percent of the employees earn less than $1,225 a week? So in other words, what percent of the salaries are less than $1,225? Now, remember the general box plot that I drew up here and how the different percentages are distributed, right? So to the left of Q3, we would add up 25%, 25%, and 25% for a total of 75%. And you could even label this if you want on the picture. So we have 25%, 25%, 25%, and then the last 25%. So what percent earn less than 1225? We said that's all the percentages to the left of Q3. We have to add them up, right? So that's going to be about 75% that are earning less than 1225 a week. So B says, what percent of the employees earn between 510 and 1225 a week? So 510 and 1225, that makes up the box, right? Because 510 is Q1 and 1225 is Q3. And about 50% of the data values are within the box. So the answer to this is going to be about 50% of the employees earn between 510 and 1225 a week. So part C says compute the IQR. So now I'll go over the IQR. IQR stands for interquartile range. And the interquartile range is the range of the box, the rectangle. So the IQR, the interquartile range, is the difference between Q3 and Q1. It's the measure of spread within the distribution. So the interquartile range is equal to Q3 minus Q1. So in this case, Q3 is 1225, and we have to minus Q1, which is 510. So if we take 1225 and we minus 510, we get an interquartile range of $715. Now, we can use the interquartile range in order to determine if a specific data value should be considered an outlier. So here's the rules for detecting outliers. So we have what's called the inner and the outer fences. If we take 1.5 times the interquartile range, and we add that to the third quartile. So if we go a distance of 1.5 times the IQR above the third quartile, or at least a distance of 1.5 times the IQR below the first quartile, we can consider these values potential outliers. Those are the inner fences. Now we can also calculate the outer fences, which are going to give us data values that are even further away. So the inner fences are located a distance of 1.5 times the IQR below Q1 and above Q3. The outer fences are located a distance of 3 times the interquartile range below Q1 and above Q3. So if we use this idea of inner and outer fences, we could set a rule now for detecting outliers. So an outlier is any data value that falls outside the outer fences. A potential outlier is identified as any data value that falls between the inner fence and the outer fence. So in part D, I'm asking, should a weekly salary of $3,700 be considered an outlier? So 3,700 is here, right? That's the maximum value in the set. And we're curious to know if it should be considered an outlier. So in order to determine this, we have to figure out the inner and the outer fences. So to get the upper inner fence, because I don't really care about the lower inner and outer fences, because 3,700 is to the right of the interquartile range, right? It's up to the right. So what we're going to do is let's take 1.5 times the interquartile range. So we're going to get 1.5 times the IQR, which was 715. So that's going to give us, so let's multiply. So I'm just going to do this on my handheld calculator. So 1.5 times 715 is 1072.5. So this is going to be my upper inner fence. And then if we take 3 times the interquartile range, so if we take 3 times the interquartile range, which is 715, we're going to get 2145. And I apologize for that previous step. So this is not the upper inner fence. We have to add this to Q3. So we're going to take 1.5 times the interquartile range, and we're going to add it to the third quartile. So now let's take the third quartile, which is 1225, and we're going to add that to 1072.5. And we're going to get 2297.5. So this is my upper inner fence, 2297.5. And now I have to take 3 times the interquartile range, which is 2145. And I'm going to add that to Q3. So I'm going to take 1225 plus 2145. And we're going to get 3370. And this is going to be the upper outer fence. So anything that lands between the inner and the outer fence, we're going to consider a potential outlier, and anything that falls beyond the outer fence is going to be considered an outlier. So the question is, Should 3,700 be considered an outlier? Now, 3,700 falls beyond, right, 3,370. It's bigger than that outer fence. So we're going to consider it a potential outlier. So yes, since 3,700 is greater than the outer fence, the value of the outer fence, right? And then last, what is the shape of the distribution of these salaries? So I'm just going to erase this that's drawn on here because I think it's just going to be easier to see in order to determine shape. So like we've been doing every time we want to determine shape of a distribution, we kind of lightly take our pen or a pencil and we outline the shape of the distribution. And we have this outlier, right? This 3,700. So I'm feeling like this shape is definitely going to be skewed in the direction of the outlier, right? Which is to the right. So the shape is going to be skewed to the right. And we kind of see that too because of that longer whisker on the right-hand side, right? That's what I was talking about before when we have one whisker that's noticeably longer than the other. So now I have one last example where I gave you a bunch of different box plots that represent the average monthly temperatures of 6 different cities in the US, and we have to answer some questions. And then we'll wrap up the lesson. So we have temperatures for New York, Woodstock, Miami, Juneau, Honolulu, and Grand Forks. So the first question says, which two cities tend to be the warmest? So these box plots are vertical. The other ones that we were looking at were horizontal. You could draw them either way. In this case, since we were drawing 6 of them, it was saving space to draw them vertically. So then my horizontal axis just becomes my vertical axis. So think of, just for example, look at this first box plot for New York. This value down here is the min. Then we have Q1, then we have Q2. This would be Q3, and then here would be my max. So just imagine looking at this box plot on its side, right? And then that's going to look like the ones that we've been drawing. So which two cities tend to be the warmest? Well, here's the warmest temperatures up here, right? And we see these two box plots sitting higher than all the rest. So these cities are going to have the warmest temperatures. So these two cities happen to be Miami and Honolulu. So the next question says, which city tends to have the lowest temperatures? So we want to look for the whisker that, is the longest in terms of going down to the lower temperatures, right? So which box plot tends to, gravitate towards the lower temperatures? And if we look at Grand Forks, right, we have a min all the way down here, which seems to be in the lowest temperatures compared to all the other cities. So the city that tends to have the lowest temperatures is going to be Grand Forks. So the next question says, which city has the least variation in temperature? Now, I talked about this earlier in the lesson. So we said that the box that's has the shortest distance, so the box that's more narrow is going to have the least variation, and the box that's wider or longer is going to have more variation. So if we look at all these different box plots, the one that has the least variation in temperature, or the smallest box, is going to be Honolulu. So Honolulu doesn't seem to vary in temperature much, right? It kind of hovers between 75 and 85 degrees. And then let's look at one more. So part D, which city has the most variation in temperature? So the city that has the most variation in temperature is going to be the city that has the longest box. And it seems that the longest box is the box for Grand Forks, right? Because the max temperature seems to be close to 70, but then the min dips all the way down to single digit temperatures. So that one seems to have the most variability or variation in temperature. So this one is going to be Grand Forks. And this wraps up the chapter 3 material. So we are finished with chapter 3. The next lesson will begin chapter 4, and we'll start talking about correlation and regression.